In the next couple minutes, I'm going to give you a basic overview of how to run the simulation, the first of the two simulation demonstrations. You can see here I have open a synchronous assembly, and it's called the mower blade assembly, And when you first come in, you're going to have Pathfinder and you're going to have your Home tab. What we want to do is we want to switch over to the Simulation tab, and we will come down to Pathfinder and select the Simulation tab there as well, so we can see what we refer to is Study Navigator. Now you're going to note that, or I will note here, that we've got 3 studies already created with results already created in the study. So what we want to do basically is change this button. It's called the Show Single All Studies, so that we're just looking at the first study, which is a modal analysis. Now, in order to replicate this and show them how we can apply loads and stuff, even though they've already been applied, we basically have turned off those constraints that were on this for this particular study. So to begin, what we'll want to do is to show them how easy it is to graphically, in this case, attach a fixed constraint to the bottom of the hub. So you just simply select that bottom face and accept it, and you'll notice it attaches that fixed graphic. Now once that's done, because it's a modal analysis, we're not really using force here, so we can turn off that graphic, and then we can also go to the connectors and use the auto option under connectors to let the system automatically go out and find the connecting faces between these parts in the assembly. We're going to use a 1 millimeter search distance, and that's how far it will actually search for other parts in the assembly. We will select the All Components option. It finds all of the components in the file. We can accept that. It builds a list of the connectors that it's going to build. If that's okay, you would accept it at that point, and it will build those connectors. And you can see how it graphically shows them on the screen. So at that point, we'll go ahead and turn those off, click in the view to remove the connector, and then what we're going to do is click on the mesh command. Now the mesh has already been created, so basically what it's going to do is just simply display the one that was already created. But again, this allows us to get through this demonstration quickly. For the movie, I did click on the solve button just to show them how we start to solve, but then I click on the cancel button because it has already been solved. At that point, you can just simply go to the results and view the results previously created. Now, you'll notice here that it gives us options to view the different modes that were created. In this case, we set up to have 6 modes created. And you can easily pick one or the other to look at. Or you can use the green down arrow to go down through each one of the modes and display each one of them. So as I click on these, you'll notice how it shows the different modes from the modal analysis that we ran. The next thing that we want to do is to close the simulation results, and we want to go to our next study, which is basically a linear static study of this particular model. In order to show this, we're going to apply a constraint and a force. So let's go ahead and apply a fixed constraint again to the bottom of the hub and also to the side of the blade. What we want to do is simulate this blade actually hitting a rock or some ground as a person is mowing. So to actually stop the blade and stop the hub. So those are going to be fixed. And then we're going to come over and apply a force to the front of our blade. By simply selecting this angled face, you'll notice that it gives us an arrow showing us the direction of force. 1,000 newtons is fine for this, so we'll go ahead and click on the steering wheel, and we're going to attach it to the side face just to show how easy it is to change the direction of the force. Notice the primary axis shows the direction of the force. As I click on that and put it on this top face, and then use my shift key and select that inside blue plane, it will flatten out, and you'll notice how that arrow changes. Again, by holding the shift key down and selecting the knob on the outside, I'm just going to simply rotate it toward the front, and you will see how the force direction is applied here. At that point, we can go ahead and accept it. Now what we're going to do is go ahead and turn off our loads and constraints. Again, click on the mesh. Even though the mesh has already been done, it's going to show us that particular mesh. And then at that point, we can go on in and take a look at the results. Again, these results were created ahead of time. Now as we come in here, you'll notice that it shows us where we've got some stress, and if we want, we can animate that by just clicking on the animation button. It does give you some options for animation, and you can turn on and off the contour during that. You can set colors. You can turn on the undeformed model during animation, depending on what the user wants to see. Some other options that we have, if I zoom up on this to kind of let you see them a little bit better, we have options to turn on contour styles. Now what we're looking at here is a smooth contour. I can change it to banded, and you'll see how not only the color bar but the actual graphics on the parts change to a banded type style. We also have element, where each element picks up the major part or portion of that element and shows you the color for that particular element. So we're going to go back to the smooth contour, and then what I'm going to do is zoom out a little bit and just take a quick look at probes. Now what probe does is it allows us to actually select different nodes, and it will give us node information right on our cursor, and then I can simply click to place that. I can do it several times, as many as I want. And so you can see here I'm going to just basically match up the node information with the color that it's given me. We also can show displacement. So if I pick this, you'll notice that I get a deformation line on the bottom. So this kind of gives us some good feedback from the actual nodes on the model itself. Now this is basically the end of the first portion of this demonstration. So we'll go to the second demonstration in just a minute.